for the purposes of class discussions and those things, that this is potentially going to be of some benefit to you guys. All right. So let's look at what we've got here. So we'll start off with group 4, saying breast, skin, lung, ovarian in women, prostate in men, and leukemia. So group 3 had skin, lung, breast, leukemia, and prostate. So we've got basically the same 5 minus ovarian cancer in that one. Preston had, so group 5 had breast, skin, colon, lung, and leukemia. And then group 1 had skin, prostate, colon, lung, testicular. But then we flipped that around and we've added breast and ovarian in women. And then prostate, breast, colon, skin, and lung. Okay. So if we look at all of these, there seem to be some that are kind of very widely put on there. So would it surprise all of you guys to know that one of the ones that you guys have listed is actually not one of the most common ones? It's actually not in the top 5, especially for women. You guys want to guess what that one is? You all have it.
Breast cancer.
No, actually, Tyler, that would be a good guess. But no, as it turns out, breast cancer is the most common form of cancer in women. So it is number 1 in women, and it kind of would, you could argue that it's number 1 overall. That's the single most common kind of cancer. So good guess.
The skin cancer?
It is indeed skin cancer, Lindsay. Okay. So I know that it seems like it should be one of the most common ones, but it's actually not. Okay. So breast cancer is 1 in women. If you guys had to guess, if it's not skin cancer, what do you think is number 1 in men? And it's really important. This is going to be one that's going to be really important. To my guys that are in the audience here.
Is it prostate?
It is, Tyler, prostate cancer. So breast cancer and prostate cancer are by far the most common forms of cancer. Okay. It dramatically outstrips all of the rest of them. So, you know, ladies, y'all are probably a good 20 or 25 years from probably having to get a mammogram every year to check for breast cancer. And they keep moving the age ranges up on all of those things. And so, guys, y'all are sort of in the same boat. You know, we usually are going to be in our 40s before they start kind of telling us every year that we should go in and have our prostate checked. But given how common they are, that might not be a bad thing. Okay. So what do you guys think about the next one? So if breast and prostate is 1, okay, it's 1 in both men and in women. Okay, those are there. What do you guys think should be 2? 2 is pretty common, pretty much similar in both men and women. Lung cancer. That's right, Preston. That's right. So lung cancer. So given the big push with smoking and those things, and so, but it's not just smoking. Any kind of environmental pollutant is going to potentially kind of do that. So you have, especially people in like West Virginia and places that work in coal mines, they're going to end up getting a lot of those kinds of things. Okay. And so then it begins to diverge a little bit between men and women with colon or colorectal cancer. All right. And then kind of it moves on kind of down from there. Okay. And we'll walk our way through those. So what I'm going to do, I think at this point is, oh no, I can't do that. Okay. So what I'm going to do is I'm going to go ahead and pull up the slides, and I'll share my screen. We'll talk about prevalence a little bit, Then we'll come back and we'll talk about the ones that are the deadliest, okay? But while I'm doing that, while I'm kind of getting this stuff pulled up, why don't group 3, whoever is running things for group 3, why don't you tell me what you guys came up with as your definition of cancer, please? Anybody?
Okay.
Group 3?
Yeah, sorry, I had to get it pulled up. We
Okay.
define cancer as a collection of cells that grow uncontrollably and infect other cells.
Okay, that's right. They're going to a collection of cells that are going to grow uncontrollably. Oh, this is strange. Okay. So I apologize, guys, for what these are going to look like because I don't have another file. So it looks like when I taught with these in the spring, I was using my tablet, and I wrote on the slides. I wrote like notes and arrows and things on the slides, and it saved them on there. And so again, you guys can see kind of in some ways how unprepared or ill prepared I am. But given where I am, I don't have another copy of the PowerPoint out here. So we're just gonna go with it, and maybe my chicken scratch will make sense for you guys. Okay. So what you guys got was very much correct. Okay. Cancer is, or a cancerous group of cells, are cells that have uncontrolled growth. Okay, uncontrolled growth. And so the fact that some cells in your body are naturally going to grow more or divide more often than others is going to determine some of kind of which cells are going to be more likely. There's a reason that cells that are under the influence of sex hormones are going to, you're going to have a lot of cancers that are going to be there. You're going to have things like leukemia and lymphoma, things that are coming out of blood cells, because these are cells that are normally dividing very fast anyway. And so you're gonna have some things that are going on there. Okay. So one cell begins to grow, it begins to replicate itself over and over again. And so then when that happens, you're going to get the formation of something called a tumor. Okay. Or in the most kind of scientific way, it's called a neoplasm. But a tumor is a group of cells. Okay. So everything starts with one cell. That cell splits and you've got 2, and then they split again and you've got 4. Okay. And as that begins to kind of ramp up and grow uncontrollably, the group of cells is going to be collectively called a tumor, right? And so as you can see down here in this illustration, you've got what a normal cell looks like, and then here you have this group of cancerous cells. This would be a tumor that has begun to form here. And what I want you all to look at in this picture is that cells that are part of a tumor, cells that tend to grow uncontrollably, they're very often not going to look like regular cells of that same tissue. Okay. Normally, cells are highly organized. All the cells in a tissue that are of the same type are going to look very, very similar. Okay. They're all nice and neatly organized. They have these very well kind of defined edges. What you see with cells that are part of a tumor, they're growing so fast is they're not nearly as organized. They're going to not have they're not all going to have the same shape to them. They're going to be big and lumpy and just kind of spreading out all over the place. Okay. That's a hallmark of cells that are part of a tumor. Okay. And the extent to which they look more abnormal than regular cells is going to be a hallmark of, as we will talk about in a few slides, if we have what's called a benign tumor or a more malignant tumor. Okay. So the faster the cells grow, the faster the proliferation rate, okay, the more unorganized the cells are going to be. And those are going to be the ones that are going to be the most dangerous. Okay. So when we talk about cancerous cells, And this will lead us into then kind of the types of cancers that we're looking at. We classify and we name cancerous cells or these tumors based upon the cell type that it originated in, okay, and the tissue that that particular cell type is going to come from, okay? So when you see things referred to as carcinomas, okay, a carcinoma originated from what are called epithelial cells. And I don't want to spend any more time than just kind of mentioning that there are these things that are called epithelial cells, okay? We're not going to talk about how their epithelial cells are different than others, but almost 80% of all cancers come from epithelial cells. But almost all of your tissues are going to have epithelial cells. They're going to have other types as well, but they're going to have epithelial cells that are going to be there. Leukemia, okay, is coming from a hematopoietic cells. These are coming from bone marrow, okay. Lymphoma are things that have come from lymphocytes. So these are immune cells, which have also come from, from bone marrow and those things. A sarcoma has come from mesenchymal cells. So this is going to be connective tissue type cells. So we name them. You will have, like a, squamous carcinoma from the lung or something. And so that's how we name these things out. You don't have to know this, but as you guys will see, cancer is very, very common. Somewhere between maybe a third to 50% of us in here, right? So as you guys will see, ladies, about a third of y'all will have breast cancer at some point in your life. Guys, 1 in 2 of us will probably have prostate cancer. You can argue that your prostate is just a group of cancerous cells no matter what. And so you're going to see this in your own life. These are kind of how you're gonna see things in people that you're close with. So I just want you all to know they're gonna come in and they're the oncologist gonna say, oh, you've got this, this, this. That's where those names come from. Okay. So if we look at some kind of facts before we get into the ins and outs of the most common and the most deadly, is that about half of men and about a third of women will develop cancer at some point in your life. And so what that means is that in those numbers, right, the most common forms are going to be breast and prostate, okay? It can originate in any organ type, does not matter. And then they can also have the potential to spread or metastasize by moving from one tissue to another, okay? Tumors that metastasize, these are the ones that can do the most damage. These are the ones that are the most difficult for us to treat. And so, you may have a cancer that begins in, I don't know, in the bone marrow, in your femur, but it may migrate to the brain, or it may migrate to your lungs or your pancreas or something like that, okay? So almost a quarter of all deaths in the US each year are going to come from cancer. There's almost 1.5 million new cases of cancer a year. The healthcare costs are, in the hundreds of billions of dollars that we're going to have. On a positive note from all of this, the 5-year survival rate from all forms of cancer has increased so that now about 65% of people that are diagnosed with some form of cancer will live an additional 5 years, okay? That might not seem like much, but that's progress, okay? That's progress. So we measure this, we measure cancer survival rates in 5-year increments. So some people, the cancer will be gone, it will never come back, it will never be a problem again. And you're going to get some people that it will be gone, or we can't even get it to go away completely, but we're going to try to have them hang on and live in some ways as long as they possibly can. Okay. So I told you guys already that there are 2 types of tumors. There's benign tumors and there's malignant tumors. Generally, they're both forms of cancer, okay? But generally, people consider the malignant tumors to truly be the cancerous tumors, okay? Because benign tumors are slow growing. They do not tend to migrate from their tissue of origin, so they can much more easily be removed. And they are going to be what we call encapsulated. So it's going to be these little collections of cells that have their own capsule around them, so those cells can't like escape and can't go anywhere. Okay. Typically, benign tumors are not going to be fatal. Typically, they're not going to be. The problem is that in some instances, benign tumors can become malignant tumors. They can spread, or they can go from growing slowly to growing much, much faster. Okay. Malignant tumors grow very rapidly. Because they're not encapsulated, they will leave their tissue of origin. They will attempt to go and invade other organs. Okay. And so the way that cancer cells typically that they will typically lead to death is that cancerous cells are going to they're going to steal the blood supply, and they're going to steal the nutrients away from the regular tissue that they're in. And because of that, then normal healthy tissue will begin to die because it is not getting enough blood, it's not getting enough nutrients, and so those cells can't live. And so then what happens is that the cancerous cells migrate to the lungs, and they lead to deterioration of healthy lung tissue. And then, when that reaches a certain point, then that becomes a problem. Okay. Or you've got pancreatic cancer and it's going to do things, and then you're going to stop, producing normal insulin. You're going to lose normal organ function, and that's how that's going to end up being a bad thing. Okay. Cancers develop through changes in the DNA of a particular cell. Okay. That change in DNA is called a mutation. We will get into the origins of some of these mutations, okay? But any change. Every one of you right now, every one of us sitting here has cells that have undergone mutations in our bodies right now. They mutated this morning, or they mutated yesterday, okay? We all very likely have early stage cancerous cells in our body right now. Okay. But the body's really, really good. Okay. It's really good at recognizing when a mutation has happened. And when you get cells that are growing faster than they're supposed to, then the body is really, really good at finding those cells and killing off those kinds of cells. And so we all develop early stage tumor cells very often. But the immune system, we have these systems in place that are going to be really, really good at catching these things. Okay. So how does this happen? Okay. How and why do mutations lead to cancer? Why do they lead to these rapidly growing cells? Okay. So the central dogma, the central idea behind everything is that when cells need to grow, okay, you have to take DNA, you have to unzip that DNA and go through a process of what is called transcription, where we're going to open up the DNA, we're going to read our genetic code, and that's going to make RNA. Okay, then that RNA is going to move off, and it's going to go to a ribosome, and we're going to undergo a process called translation, where the RNA is going to signal for us on what particular protein or amino acids we need to bring in, and then we're going to hook our proteins together. Okay, so DNA has the original code to tell the cell to make things. It tells the cell to do things, okay? And so if a cell needs to replicate, it's going to have to make new proteins. It's going to have to make new membranes. It's going to have to do a whole bunch of different things. All of those signals are contained in the DNA, okay? So inside all of this, all right, in a normal cell, when a cell needs to divide, right, it's going to kind of very orderly open up its DNA. It's going to make, one cell is going to become two cells, right? Here we have in cancerous cells where the division is going to be, kind of crazy, and things are going to happen, all right? So what tends to happen, and I apologize for all of this, I will find a clean version of these and repost those for you guys. That's my apologies for all of this. Okay. But when cells replicate, they undergo a process called mitosis. And so generally, if you have a cell and it's been damaged and you need to either repair the cell or make a new cell, then it undergoes mitosis, and then the new cell is going to arrest the cell cycle down here in this what we call G0 phase. And so then it just becomes kind of a frozen, normal functioning cell. It is no longer trying to replicate itself. In cancerous cells, it will make a new cell, and then those cells will never arrest. Okay, they just keep going and going and going and making new copies of themselves. So this normal idea of a cell cycle and how that process takes place through mitosis, it doesn't stop the way that it's supposed to. There's no breaks or there's no checkpoint where it's run through all of the checkpoints and how it's going to get to those places. Okay. All right. So where do these mutations come from? Okay. And so there are several places that this is going to happen. There's several, I guess, origins of things that cause this damage in the DNA, that cause these mutations. And these mutations can be as small as a mistake in one base pair in the DNA. You change one base pair, and because of these in the cell cycle, there's genes that say stop. Okay, there are genes that say start, and so if you get a mutation in what's called a stop codon, where it's not going to shut off the way that it's supposed to, one base pair different, and it's not a stop, it's a keep going. Or you've got a thing where you change one base pair and it turns this gene from doing one thing now into a gene that says make more, make more, make more. Okay? So it can be these very small changes. This is going to come from the typical things that you guys think about, right? So exposure to ultraviolet light. So you're outside, you're getting sun, you're going to a tanning bed or something like that, you're exposed to UV light, that can cause that. Okay, UV light is not great for us, but in the range of things that cause cancer, it's a more milder kind of a more mild agent. There's what's called ionizing radiation, and this would be like radiation from X-rays or things that would be worse, like ionizing radiation coming off of, say, like a nuclear reactor or something. Okay, something that is radioactive. Much, much, much more potent at all of these things. Okay. And so again, your exposure to these things is due to how much radiation is coming off of something and how long have you been exposed to it. And so you can kind of calculate this dose that you're going to get. Whereas like having a couple of x-rays done, not a big deal. Okay. But if you're going to, sit and work in the x-ray room, be right there for days and weeks on end, then it can become an issue. Additionally, exposure to certain chemicals can cause mutations. There's a lot of chemicals. It would take us all day to kind of go through the entire list, but like cleaning products, you guys may have just seen that I think it's Bayer that makes, or that owned Monsanto, that makes Roundup, the weed killer. And they just had a big settlement with things, but there's one of the chemicals in the weed killer Roundup causes cancer. Okay, it is a carcinogen. There can also just be some things that are normally going on. You replicate your DNA a huge number of times every day, and every once in a while there will be errors in replication. They're just simple errors. And sometimes we catch those, or most of the time we catch those, but sometimes we don't. There can also be some errors due to what's just regular cellular metabolism. When your body is making energy, you're going to create some of these reactive oxygen species. If they get exposed to DNA, then they can also cause those things. Okay. Normally, what happens? You get a mutation. and it gets caught. And if it gets caught, it will either get fixed and the cell will function normally, or if it gets caught but it's kind of after the point where it can get fixed, then those cells normally undergo something called apoptosis, which is called programmed cell death. So the cell recognizes that there's been a mistake in the DNA replication, there's been a mistake in trying to make some proteins, it catches it. We can't go back and fix it, so the solution is just kill this cell. Okay, it's basically cell suicide. And so by doing all of that, then there's no chance for that cell to continue kind of growing uncontrolled. Okay, so we've got some of these things. When mutations take place in certain genes, those are going to be the things that are going to most commonly cause cancer. And so these are going to be mutations in what we call oncogenes. Okay, and what we call oncogenes. Oncogene just means genes that can cause. They mostly deal with either turning a cell and its proliferation on, or stopping, okay, a cell from further replicating. So when you get a mess up and it says keep going, turn on, make new copies of yourself, or don't stop making copies of yourself, those are going to be the mutations that are going to typically lead to all of those. Okay. You also have what are called tumor suppressor genes. And so if you get mutations in the tumor suppressor genes where they normally will kind of stop stuff, then you're going to continue to get things like that. Okay. Tumor suppressors act like a brake pedal, as it says. And so they're going to slow down growth. They're going to put a halt to all of this. So mutations in genes that turn the cell on, or mutations in these genes that are going to suppress cell growth so that you're not getting the suppression. Both of those things can cause all of this. All right, we're going to come back to the risk factor. We're going to talk not about mortality first, but about incidence. Okay, so here's where we are. Okay, these are some data from 2019, and this is the rate of people that are going to get this cancer per every 100,000 people. Okay, and so what you guys can see is that breast cancer is by far the most common form of cancer. By far the most common form. Okay, prostate is number 2. All right, also dramatically ahead of what is going to be what's going to be third, or if you want to split it based upon men and women, what would be second in each of them. So then you've got lung cancer coming in next. Then you're going to have colorectal cancer. So cancer basically of the large intestine or the rectum. And then after that, then the prevalence numbers are really going to begin to kind of blend together and shrink down quite a bit. So you've got uterine cancer, then you're going to have skin cancer, bladder cancer, non-Hodgkin's lymphoma, kidney, thyroid. Okay, so these are going to be those things. So you're going to see we've got breast and prostate, you've got uterine cancer, right, and those are going to be. And then if you were to pull them out individually by men and women, if you were to look at their top 10s, you're going to see testicular cancer, you're going to see ovarian cancer, you're going to see endometrial cancer. And so these tissues that are under the influence of the anabolic sex hormones are all going to have higher rates of development of cancers. Okay, lung cancer, you're going to have higher rates there due to environmental exposures, especially smoking. There's lots of things, agents in tar and cigarette and cigar smoke that are going to lead to mutations. I'm sure at some point we'll figure out that some of the chemicals in vaping probably do the same thing. We will see. Colorectal is next because this is going to be oftentimes due to exposure to carcinogens in food. Okay, things that you've eaten may have trace amounts of chemicals or carcinogens in them, and so as that stuff doesn't get absorbed in the small intestine, as you're getting exposed to it, as it moves its way through the colon and into the rectum, then you can get some exposure to things there. Skin cancer, mostly due to being exposed like out in the sun. Okay. All right. Questions about any of that so far? Okay. Then what I'm going to do is we're going to pause the sharing, and we're going to pause. All right. So those are the most common forms of cancer. Okay. So let's talk about the most deadly. And this was maybe one that would be interesting to see kind of what you guys all came up with. Okay. So the most deadly form of cancer is lung cancer. Okay. One, it's very, very common, but two, if you get lung cancer, there are very, very few treatments that are available. Okay. So how many of my groups, how many of you guys actually, you got lung cancer on your most deadly?
We put lung cancer on our most deadly.
Okay. Lindsay's group had it on there. My other groups, anybody?
We had it in ours.
Okay. Good. Well, that's a good one. So breast and prostate very often tend to be the kind of second and third most mortal or deadliest types of cancer. They are, in comparison to lung cancer, not nearly as severe. We have much better outcomes, much better treatments for breast cancer and for prostate cancer, but they're so common. Okay, they're so common that that just because it is so common, that some people will get very kind of very nasty forms of it that are not very treatable, and that becomes an issue. Okay, so we have to kind of keep all of that in mind. Sometimes people don't think about like, oh, I've got breast cancer, oh, I've got prostate cancer. It is wherever it is. We've caught it pretty early. We can normally do pretty well, but for some people, it can be really kind of really bad. Next is colorectal cancer. Same thing. We have reasonable outcomes for colorectal cancer, especially if we catch it at a reasonable time. But because it tends to be pretty common, then the numbers kind of add up on us. Pancreatic cancer is fifth, and so much like lung cancer, pancreatic cancer is very, very deadly. It's not particularly common, but it's really bad if and when people get pancreatic cancer. Okay, so that's going to be kind of where a lot of that comes from. Okay, so we'll talk a little bit more about which of these our mortality rates and our prevalence rates can be positively impacted by physical activity in just a few slides, but that's kind of the ones that people tend to get the most, and then the ones that are going to tend to be the most more. Okay, so before we jump into kind of how physical activity can affect things, we need to talk about what are your risk factors. Okay, what's going to make you be at a higher risk. So like everything else that we've talked about, heredity is a big deal. Okay, heredity is a big deal. Some particular types of cancers do tend to run in families. Okay, prostate cancer, breast cancer especially, do tend to run in families. Okay, it's only a small percentage. You're not quite as likely. There's higher hereditary things for cardiovascular disease and diabetes, but there is going to be a part that's going to be in there. Most mutations are generally not going to be passed on from parents to children. Okay, that's why when you go to get an X-ray, they put the lead plates where they're going to cover women's ovaries and they're going to cover guys' testicles. We're trying to keep the exposure of eggs and sperm to these carcinogens in some ways. Okay. So breast, as I said, breast, ovarian, colon, and prostate do have the greatest familial links. The primary way that we end up with getting cancer are going to be exposure to environmental carcinogens. Okay, exposure to things in our environment or behaviors that are going to make it more likely that we're going to end up with DNA mutations. Okay, so the number one, the single most common one is smoking and tobacco use. Okay, smoking and tobacco use. If being sedentary is the second leading preventable cause of death, right, because of its role in cardiovascular disease and diabetes and a little bit in cancer, smoking is number one because it plays such a big risk in causing lung cancer. Okay. A second environmental carcinogen is exposure to UV light. So anytime that we go outside, what we're going to want to try to do is wear sunscreen or wear a hat, wear sleeves and things. For Father's Day, my wife got me this very, very light long sleeve shirt that has, like, the shirt is like wearing SPF 50 sunscreen. Okay. And so we're out with Ellis a whole bunch. We actually have, Ellis has a little shirt like that. It keeps us from having to slather her up in sunscreen all the time. Yes, it's hot to have to be like, it's 95 degrees outside and I'm wearing a long sleeve shirt. But if the potential other thing is, you're exposed to UV light and you're increasing your cancer risk, then we just kind of deal with that. Anytime when I go out now, I'm wearing like a fishing hat a lot of the time. So one of those kind of hats with the big circular wide brims as well that I'm out with Ellis a whole bunch. I try to wear those. When I played golf last week, I wore one when I played golf. I've truly become, right, like I've become uncool, like dad clothing wearer person. But there is we're outside a bunch, and I've spent a lot of my life outside, and so you want to try to kind of limit your risk as much as possible with those kinds of things. Okay. Environmental pollutants and chemicals are going to be another thing. Stuff that's in the food that you eat, the water that you drink, what you may be exposed to as part of your job, and those kinds of things. You guys, if you live in Norman, it's some kind of chromium, I believe, that is in the water from Lake Thunderbird, and it's the Lake Thunderbird has like Norman water has the highest level of that is allowed by the FDA anywhere in the United States. And so every year they come and they test whatever it is if you've seen the movie Aaron Brockovich, whatever the chemical is that, I believe it's heavy some kind of chromium something in Aaron Brockovich that causes all of the cancers. That same stuff is I believe it's in Lake Thunderbird. It's in the Norman water supply.
I know that Norman has a really high level of arsenic in their water too.
Is it arsenic as well, Tyler? Okay.
They have a lot of arsenic in their water.
Okay.
Obviously, it's below the limit or whatever.
It's below the limit. So I thought it was maybe I've read the thing wrong. But anyway, so when we lived in Norman, we did not ever drink tap water. We didn't give our dogs tap water, which is how kind of the out there people that that we are, on just the chance that it's on these allowable limits and whatever. You can look at what the kind of allowable dose of things is going to be, but it's still really still very rare. But anyway, okay, things in your diet, when you overcook your food, like when you eat, if you're like me and you like very well done like steak and those things, which you guys can all make fun of me for that, that's fine. But like things when it gets burned and stuff, there's actually carcinogens that are going to be in there. People will argue, there's always data coming out about, is red meat in fact a carcinogen? People that eat red meat, there is some evidence that they do tend to have higher rates of cancer. Is it totally due to the red meat, or is it due to you eat more red meat, then that's going to be linked to obesity, and is it the obesity that's causing the cancer? That there's some debate about all of that. Okay, but diet, being sedentary, overconsumption of alcohol, especially for liver cancers and things, all of which kind of diet and sedentary are related to obesity. So really, obesity, we are learning that obesity can be a carcinogen, especially for like breast cancer and those kinds of things. And obesity plays a really big role. Partially because obesity is going to exert some control on especially estrogens. Okay, so there's some interesting things that are going on there. So you can imagine then a scenario whereby if I exercise and I'm more physically active, then maybe that's going to have some influence on my diet. That may have some influence on the hormones and things. That may have some influence on obesity. And so therefore, because of all of that, exercise may be able to exert some level of protection from risk of certain kinds of cancers. Okay. So what does exercise do? So we're going to take this, and the first couple are really going to be the kind of the most powerful ones that we're going to have. Okay. When you are more active, the more that you exercise, there's going to be this moderating effect on insulin. Okay. Because exercise is also going to drive glucose into cells, and exercise makes your insulin receptors function better. So people that exercise more have fewer and less steep spikes in insulin whenever they're eating. Okay, and we do see that these kind of repeated big spikes in insulin does signal through that pathway that leads to cell growth or has some crossover with all of that. And so moderating the effect, those kind of things with insulin does seem to have some protective effects. Exercise and physical activity, especially very, very high levels of aerobic activity, can actually lead to decreases in testosterone. Okay. And these decreases in moderations of testosterone can be protective for prostate cancer, but you've got to be really, really, really active, guys, really active. Okay. And then there is some moderation of estrogen levels with exercise, but we'll talk about this. I guess we can go ahead and we can do it now, especially as it relates to breast cancer. So ladies, do you guys know, I could ask all of you to tell me one thing, okay? To tell me one thing about you, and I could fairly accurately predict which of you, based upon that one thing, are going to be at the highest risk of developing breast cancer. Do you guys have any idea what that is? I need one piece of information.
Would it be if you take a hormonal birth control?
So that's a great guess, Maddie, and it is somewhat related to that, but it is not due to hormonal birth control per se. But you're on the right track. You're close. Anybody want to guess? Okay. I'll ask the question in a different way. We'll see if you guys can kind of back your way into it from a critical thinking standpoint. So I'm from Arkansas. Has anybody seen the TV show about the Duggars? So the Duggars are from Springdale, which is just down the street from where I grew up in Northwest Arkansas. Has anybody seen the show about the Duggars? Nobody? Guess
Don't
I'm
they have like 12 kids or something like that?
12. They wish it was 12. It's more like 20. But I think they have like 18 or 19 children. Okay. And then now their kids are old enough that some of their kids also have a whole bunch of kids, which, to each their own. That's fine. But I can tell you that whatever her name is, that Mrs. Duggar, the mom, is at a very, 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 very low, almost non-existent chance of having premenopausal breast cancer. So do you guys know what is different about being pregnant than not being pregnant, ladies, as it relates to as it relates to your menstrual cycle? Okay. I'll ask the question a different way then. So ladies, and guys, how might you know that you might be pregnant? What is typically the first sign that you may be pregnant? Nobody wants to talk, but somebody's going to type. So let me try to pull up the chat. Okay, I can't see the chat. I don't know how to get the chat to come up when I'm doing this.
There's
Cheyenne
no
said
period.
no period.
Pardon? I'm sorry, Judy. Can you say that again, please?
Yeah, Cheyenne said that like when you don't have a period would be your
Right.
first sign.
You're late, right? Your period is late. So when you are, and this has sort of in some ways broken my wife after all of this, she got so accustomed when she was pregnant to not having her period that now we have to fight with her, with our insurance company, so that she can get like a 3-month at a time supply of her birth control, so that she can just not take the placebo pills and just sort of take them constantly and not have her period. But when you miss a period, so when you miss a period, what is happening, right? Like one thing, I mean, you're not going to slough the lining of the the endometrial layer. You're not going to slough the lining of the uterus and those kinds of things. But what's also not going to happen?
Is it that fluctuation of hormones?
Right? The fluctuation of hormones does change. What does the fluctuation of those hormones do? It is going to cause something that happens in the ovaries that is going to be kind of the signal every month. You get this, right? You're going to get the LH surge and things, and it all leads up to one thing happening. Y'all are being those people today. That's okay. Hannah, what's the job of the ovaries every menstrual cycle? Do you know? Okay, Hannah may or may not even be there. Jordan, what do the ovaries do every menstrual cycle?
Do they produce eggs?
They release an egg. That's right. We have ovulation. You're going to get these changes in the hormones. You get this surge in luteinizing hormone. It leads to ovulation, right? And then the other hormones are going to, the hormones estrogen and things are going to change, which then makes the uterus more receptive. And then if you get fertilization, then it can implant. But if you don't get fertilization, then you're going to slough the lining, and that's why you have your period. Okay? So ovulation. When you are pregnant, the hormonal input changes and there is not ovulation. Okay? Women that are pregnant very, very often, premenopause, do not have high risks of developing breast cancer. Okay? So the key thing in the development or the non-development of premenopausal breast cancer is the number of menstrual cycles that you have before menopause. Okay? The fewer quote unquote or supposed cycles you have where there is not ovulation, so that we call those anovulatory cycles. The fewer anovulatory cycles you have, the less your risk of breast cancer, which is why whatever the woman Mama Duggar is, who she's essentially been pregnant her entire adult life, okay, she has very, very low risk of developing breast cancer because she's had all of these years and years and years of these anovulatory cycles. Okay, so how could I predict in you ladies who's had the largest number of anovulatory cycles, or in some ways who's had the fewest regular cycles? What one thing could I maybe ask you guys? Corey, can you help us out? Are you guys squeamish to talk about this, or is it just Friday?
I would have thought it was birth control. But I know she already mentioned that earlier.
Mm-hmm. So birth control is possibly a thing, but we got to talk about how the birth control works, Judy. So you're on the right track, but birth control, different kinds of birth control works in different ways, right? Like they control the hormones and all of that. And some of them you're still going to get ovulation. It's just going to prevent implantation every cycle, but some of them don't. So But what's another thing that we could ask?
How often you have your period?
You could ask people how often, right? If I wanted to know which of you ladies potentially had the most number of periods in your life, and that would be predictive of who is at the highest risk for cancer, what do I need to know from all of you? I mean, I guess we could just count up the number of periods, but what would be a good proxy for that? If we were to make the assumption that you are all relatively regular, which I know that's a very big assumption.
Maybe
Should it be like
how
how
old
many?
you were when you started?
I'm sorry, Hannah, can you say that again, please?
How old you were when you started having your period?
Exactly. I could line all of you ladies up based upon what age you were when you had your first period. And those of you that were, whoever was the youngest that when you had your first period, you're at the highest risk. Whichever of you was the oldest, okay, women that were older, okay, when they had their first period, they are going to be at the less of a risk for breast cancer. Weirdly enough, this is one of the things that has the strongest association with the development of breast cancer. And so physical activity plays a role in this in kind of a strange way. Women, or I guess we would almost call them sort of prepubescent adolescent girls that are more active. The more active they are, the older they tend to be when they get their first menstrual cycle. Okay. There's also a little bit of emerging evidence that the sort of adolescents that are more obese and inactive also are going to have their periods a little bit younger. And that's going to be one of the big driving factors. So it's not true in everybody. There will still be some women that were very, very active as adolescents or as prepubescent adolescents and still were relatively young. And I'm sure what you're going to ask me now is, Dr. Black, what is young? And I don't have an answer to that off the top of my head. Okay. But I know we see ranges where there can be girls that are sometimes 8 or 9 years old when they have their first menstrual cycle. And then it may be into 13, 14, occasionally 15 is kind of in that kind of normal distribution of what we're looking at in all of those things. Okay. So weirdly enough, that's a very, very strong predictor. So I could line everybody up, all of you ladies up by all of that. Okay. And so Maddie and Judy were really getting at a good thing, right? So then if we could give you birth control that prevents ovulation, right? It prevents ovulation then every month. And so you can't get pregnant because there's not going to be an egg released. If there's birth control that prevents ovulation, then that would count as an anovulatory cycle. You're essentially tricking your body into thinking you're pregnant, and there are some birth controls that do that. Then that might actually be a good thing for the development of breast cancer, at least, because you're having more of these anovulatory cycles. Okay, and so I don't want to claim to be any sort of an endocrinologist or an expert in sort of the different kinds of hormonal birth controls. And so nor did I stay at a Holiday Inn Express last night, so I don't want to administer a bunch of things, but I can envision a scenario whereby once we get maybe another generation past you guys, so like by the time I'm a grandfather, if my daughter has a daughter, that once they hit puberty, that we'll just put every sort of adolescent young woman on some form of birth control. One, because it will be good because it can stop unwanted pregnancies, but also two, because then it will limit the risk of breast cancer. And so as you guys saw, breast cancer is the single most common form of cancer that we have. So there's some small things like this that we can potentially do that are going to have things, then that will be good. Well, I think we still have a little while to go from a social perspective to kind of get everybody on board with all of that. So, okay, cool. That ran a little longer than I was wanting to, so I apologize. But so hormone levels are important. Obesity and adiposity, excess body fat, also tend to be these very kind of high predictors of things, especially again of breast cancer. Insulin is going to lead to the release of another hormone from cells that's called insulin-like growth factor, or IGF. There's also going to be the production of some insulin-like growth factor binding proteins. And so if we can moderate those things by moderating insulin levels, that's going to be a good thing. IGF is actually really important for making muscles grow, but in some other tissues, it can exert some things that are going to make us more susceptible to cancer. From a colorectal cancer standpoint, and this is one of the ones that's actually also pretty powerful with exercise. If we decrease intestinal transit time, so if we speed up how fast things move through your digestive system, then there is less time for any harmful chemicals or carcinogens to get absorbed or to be exposed to the cells in the large intestine. Then that reduces your risk of colorectal cancer. And so in a relatively crass way of thinking about this, when you exercise more, it speeds up the movement of things through your digestive system, and therefore you're going to have to poop more often. And the more often that you have to do that, the faster things move through your system, the less chance you're going to have of developing colorectal cancer. Okay. And then moderate levels of physical activity, or even moderate to somewhat high levels of physical activity, can have some improvements, lead to improvements in immune function. Your immune system plays a very, very large role in catching and killing off cancerous cells early on in their development. Okay, so if we can do something that improves immune function, that can be good. Now, very, very, very high levels of physical activity, okay, without rest and things, can actually impair immune function. So it's sort of a U-shaped or an inverted, like a mountain-shaped curve, that I'm sedentary, my immune function is something, I'm active, I'm rising up, I'm pretty active, it gets better, and then as I get too active, then it starts to come back down again. Okay, so if we can do these kinds of things, we can moderate hormone levels, we can moderate weight and adiposity, okay, we can decrease transit time, and we can improve immune function, then being more physically active, exercising more, can have some measurable, meaningful reductions in our risk of certain kinds of cancer. Okay, so people have talked about, right, in a lot of ways, the largest preventable cause of cancer that is not smoking is obesity. And so that's going to all be wrapped up in food in some ways, and how much activity we're getting, and things like that. Okay, it is especially, as I said, going to be for breast cancer and endometrial cancer in women, and then colorectal cancer, because you're eating these large amounts of food very often, so there's more exposure to chemicals in that kind of way. All right, so obesity associated cancers, right, are going to be related, right? They're kind of the second leading kind of preventable cause. So postmenopausal breast cancer development pre and postmenopausal is a little bit different. We don't really have time to go through all of those kinds of things, but there we go. So we're going to get some of that stuff. We talked about immune function and those things, and then we've got some data here at the very end that for colorectal cancer, if you increase physical activity, it's maybe a 30 to a 50% reduction in your risk of colorectal cancer. Breast cancer is probably about 20 or 25% that's going to be there, and the effect is the way that it works is a little bit different if you're premenopausal than if you're postmenopausal. But a lot of it is related to sort of premenopausal, it's related to the age of your first menstrual cycle, and then postmenopausal, it's related to obesity. Okay, guys, prostate cancer, it's about a 10% reduction in risk. You've got to be really, really active, and that can lower your testosterone levels. And so elevated testosterone levels lead to greater risk of prostate cancer. So guys that take anabolic steroids, their prostate cancer risk goes up. The prostate is an interesting tissue, or an interesting organ. Guys, our prostates have been growing basically since we were born. And so we'll talk about this because we spent a lot of time talking about the ladies' menstrual cycles. But if you look at, and this is again kind of a crass way to think about things, but given where the prostate sits, it can, as it grows, it will press on the urethra. And as the prostate gets bigger, it makes it more difficult for urine to get into, to kind of get out of the body, because it's pressing and compressing on the urethra there. And if you can't get as much out, then the bladder stays full, and you feel this kind of increased urge to need to go more often. This was taught to me in college by our physiology professor, that if you watch a little kid try to pee, which we've luckily in the like 25 years since I took, since I was starting class and everything, if you watch a little boy try to urinate, he can pee a very long distance. He can pee like a fire hose. And then if you were to ask an older gentleman, someone like my father's age, who is in his 70s, to try to do the same thing, then you get to a place where the urine the stream is very weak. It just kind of dribbles, and all of that. And so that's because your prostate's going to increase in size. And so you can make an argument that the prostate is basically, it's just cancer. It's this kind of slow growing tumor throughout your entire life. We've got better screening for prostate cancer now. You can do some prostate sensitive antigen stuff, so if you can get checked, we can catch it pretty early, and we can remove it if we need to, and we can get some pretty good outcomes. Okay, so not a lot of effect on prostate, but a little bit. We do see some positive impacts on lung cancer, but we don't really know how much of that is related to the effects of exercise on kind of how much people will smoke. And so is the exercise modulating your exposure to these environmental carcinogens through smoking? But there have been some studies in smokers, and smokers who exercise more do seem to have lower rates of lung cancer in comparison to that. The study that we put in here, Dr. Pinku and I are trying to show you guys, is it does seem to be that there is some effects in this mTOR pathway and these kinds of things. And so the exercise is actually inhibiting. mTOR causes skeletal muscle to grow, but it can also cause tumors to grow in the lungs and those things. And so weirdly enough, exercise may turn on mTOR and skeletal muscle, but it can function to inhibit it in some of these cancerous cells in the lungs. Okay, so some interesting stuff that goes on. There's another thing that goes on in people that are cancer survivors, or people that are being treated for cancer. So as I told you guys, at some point cancer is going to affect all of us. And so my maternal grandmother had breast cancer and had a double mastectomy when I was younger. And then my wife's mother, she passed away, it's been 6 years ago now, from a brain tumor. And so we found out that she had a brain tumor. It was like 3 weeks after my wife and I had gotten married in 2003. And she lived until, I guess it was the summer of 2014. And so it's going to affect everyone. And a lot of times now, because survivability rates are getting so much better, because treatments are getting so much better, then we need to have these people, after they've had chemo, after they've had radiation, after they've had the tumor removed, we need them to exercise, because there is a phenomenon that's called cancer-related fatigue, that a lot of people, especially folks that are post-chemo or post-radiation, because they're getting tissue death because of all of that. It's this somewhat unexplainable fatigue. They're just tired, they're sleepy, their muscles are weak, okay? And so because of that, they tend to become more sedentary. And we've found that if you can get people to continue to try to be active, and then to take up more vigorous exercise after they're done with things, sometimes during treatment it can be really hard, then their cancer-related fatigue is going to be less. And by having them continue to be more active afterwards, then you can get better survivability rates, and they can have better quality of life for whatever survivability time they have afterwards as well. So we pushed really hard on this with my wife's mother. She took up marathon walking and cycling and things afterwards. And we think that was probably one of the contributing factors to why we were able to get you know, an additional 11 years from her on some of those kinds of things. Okay. And so that's kind of just my pitch with all of this, that, you know, cancer is going to affect everybody. There can be some role though in physical activity being somewhat preventative and then also somewhat therapeutic after the fact. If you've got people and they've had treatments and those kinds of things. And so we have in the past tried to run some research studies with breast cancer survivors. Chemotherapy and the radiation does some really nasty things to blood vessels and everything. I've kind of helped on some studies with people up at the Stevenson Cancer Center in Oklahoma City, looking at, can we improve blood vessel function and cardiac function in these folks that have had radiation and especially chemo after breast cancer diagnosis. Okay. So there's some really interesting things going on at the Stevenson Cancer Center at the med school here in Oklahoma City. I would encourage anybody, if you guys have, you know, just kind of go up and check them out. There's a lot of exciting stuff that's going on and a lot of opportunities for, you know, for jobs and those kinds of things. One of our former master's students works there now, and like she runs exercise kind of programming for a group and does like community outreach for exercise in these survivors and those kinds of things. So there's a lot of opportunities that are available. Okay. Okay. I will, because it's Friday, I will shut up now and